Hello, my name is Brian Cristiano, and I am here today to explain to you about my 3x2 memory circuit. First off, what is a memory circuit? Well, a memory circuit is a group of registers called memory location that allows storage of one multi-bit binary numbers, also known as words. A memory circuit is often used to store certain data at desired locations. Since mine is a 3x2 memory circuit, it can store 3 words that are 2 bits long each. There are 4 main components in the circuit: address leads, memory cells, read and write leads, and the address decoder. So what we have here is a 3x2 memory circuit schematic. This is what I used to help me create my own circuit because it's very organized and it separates the different components visually. As you can see, this is the address encoder, which is supported by these 9 AND gates and 2 NOT gates. We have the read and write leads that connects to the address encoder and decoder. We have the memory cells, which determines the amount of data in the memory location. And we have these 6 LEDs that determines the memory locations of these memory cells. And finally, we have our output, which is determined from our address decoder. So let's start with address leads. Address leads are paths created by the input that indicates which memory location is to be read or written. As you can see, our address leads are A0 and A1, and that determines which memory cell will have information stored. You can see with all the AND gates, the address leads paths will only open depending on using the binary inputs 00, 01, and 10, whether it's in read mode, and when the clock button is pressed. Next, we have our memory cells. The memory cells contain the memory location for each word. As you can see, we have 3 words, and each of them are 2 bits long. They are connected to the data leads, D1 and D0, that determines the information that will be stored. D0 determines the first bit, the state of the first bit, while D1 determines the state of the second bit. Now we have the more widely spread out read and write leads. This is what controls the circuit. As you can see, that it determines whether the path of the address encoder or address leads is open, or the path of the address decoder will be open. The read it and write lead is off, then this AND gate will turn on, making the path open for the address leads. While if it's on, then it will be in written mode, opening the path for the address decoder. It determines whether the circuit should be storing information or outputting the information stored. Finally, we have the address decoder. It determines what will be outputted from the memory cells. It uses multiple AND gates to determine which memory cell is being read and whether it is in read or write mode. These lines are connected to the address leads, so we can figure out which location of the memory cells we want to read. This line determines whether it's on read or written mode. And these lines determines the output of the different memory cells. Using these multiple AND gates and OR gates, it outputs what is being stored in the different memory cells. In the actual circuit, the one that I have built, we have the address leads in yellow, the address encoder with the green wires around the 3 AND gates and 1 NOT gate. We have the data leads at the corner, the 2 black wires that connects to the three 7474 D flip-flops. The D flip-flops are our memory cells, and we have the 6 LEDs to indicate what is stored in their respective memory cell. We have the read and write lead that's connected to the NOT gate that determines whether the circuit's in read or write mode. As you can see, it's connected to both the address leads and the address decoder. Our decoder is represented by the yellow wire and connected to the blue LEDs at the end. And finally, we have our button, our clock button at the top. And whenever it is pushed, it determines when the information from the address leads and data leads should be stored into the respective memory cells.